Hello. The topic for this last question concerns coordinate geometry. And we're looking at a circle, and we have the coordinates which are 8 and 4. So that's our center point. And we're having to show that t minus 6 or 6 is outside the circle. It's pretty clear from a picture if you draw that it is outside, but you have to show it and demonstrate. So our radius is root 100, and so using the length of a line, we go from 8 to minus 6, which is minus 14, or 14, it's squared, so it doesn't matter. And then from 4 to 6, which is 2 squared. So using the length of the line, we can state then that 10 is less than root 200, if you wish. Root 200 is also 10 root 2. So again, just replacing that equal sign with the fact that it's greater than. So it's outside, it's beyond the radius. Part B, we have two tangents from t, and we're going to draw those tangents there from that point, minus 6, 6. This will remind you of a circle theorem, I'm sure, if you do the line down the center there into the center of that circle. And that's what we're showing basically in that question, where the tangent and CT, the angle between them should be 45 degrees, of course. So I can just draw that in there if you want to make it clearer. So C is our center and T is our tangent. And I do that line there down the center. So you can see it's two triangles. So our hypotenuse will be, from the earlier part A, 10 root 2. And we also know that one side is 10. So we're using Pythagoras here. So 10 squared plus, I'll call them A and B, I suppose. TA if you want. TB, so TA squared. So to rearrange that, we can use opposite hypotenuse. So sine, the inverse of sine, 10 over 10 root 2, and that should be equal to 45 degrees. So we put around 10 there as well. 45 degrees. And you can recheck it if you want. It makes sense. So using your Pythagorean theorem there. That's part B. Part C, we have two tangents again. We touch the circle as we said. Find the equation of the line for AB. So it'll be perpendicular to CT and put it in a certain form. So first of all, when we're finding the equation of the line, we always need to do the gradient and then use that equation of the line. So there's our 2 points, C and T. So 6 minus 4 all over, minus 6 minus 8, 2 over minus 14, which is minus 1 over 7. From there we know it's perpendicular. So the perpendicular gradient, you can do the negative reciprocal, is 7. So for AB, we have y minus y1 is equal to 7, bracket x minus x1, close bracket. We also need to find the midpoint to put in those. So we find the midpoint to get a point on the line. And doing that together, you'll get 8 minus 6 over 2 and 4 plus 6 over 2, which will leave us with 1, 5 as our coordinates. So plug them in, you'll get y minus 5 is equal to 7, x minus 1, which is 7. So final answer will be simplified as it's stated in the form of y equals mx plus c. Y is equal to 7x minus 2. And that's our equation of the line AB. Part D is a very common question. It's not common that it's the last question, this unit, this topic, but this last part is finding the x-coordinates of what we were given. So we have to plug it back in, we have to substitute it back into our circle equation. So x minus 8 squared plus replace the y. So as I put in yellow there, highlighted, y is 7x minus 2. And from there, break it down and simplify. 49x squared minus 84x. You can use your calculator as much as you need, but I'm sure you can do this in your head. Plus the 36 is equal to 100. So put your like terms together. 50x squared minus 100x, and the other constants, they cancel out. 100 minus 100. So 50x squared minus 100x equals 0. You can factorize that. You'll get 0, and x is equal to 2, which is in the brackets. So there are the x coordinates for A and B, and that was the last question using coordinate geometry for November 2020, Series 3.